The gambler's fallacy is the finding that people tend to expect random processes to switch. So if I'm flipping a fair coin and it's landed heads, and heads again, and heads again, remember there's a fair going, so there's not bias towards heads, you know that. Then people start to think tails is due, right? It's about time. After all, something like fair coins land heads half the time. We've got a series of land tails half the time. We've got a series of heads in a row, so it's about time we got a tails. The reason why it's sometimes called a fallacy is that if it's a fair coin, then what that means is that the tosses are statistically independent, which means that how it lands on the next toss is not at all affected by how it landed on previous tosses. So a particular fair coin is classically defined as just one that has a 50% chance of landing heads no matter how it's landed in the past. Coins have no memory, as it said. And so if it lands heads half the time, it has to be each toss, it's 50% likely to land heads.
Hello, my geeslings. This is Mother Goose Robinson Earhart here with the introduction to Robinson's podcast, number 107. And this episode is with Kevin Dorst, who is a professor in the Department of Linguistics and Philosophy at MIT. And he focuses on rationality. That's the subject of his research. And he works, even though he's in a philosophy department, he works at the intersection between philosophy and social science. And this is exactly what Kevin and I get into in this episode. We start out with why he decided to study rationality through the lens of philosophy when there are plenty of other fields. I mean, neuroscience, economics, psychology, in which rationality is also a major topic of inquiry. And after that, we go into rationality and irrationality more particularly. We start with the classical theory or theories of rationality, Bayesian theories. And then we go into some ways in which the empirical literature has shown us that humans do not always act as we expect that they should, given these models of what rationality ought to be like. So we touch on the hindsight bias, the gambler's fallacy, sunk cost reasoning, some other instances of irrationality. And then we move on to Kevin's main focus at the moment. Well, I think it's his main focus. He's working on a lot of things, but that is political polarization, which is one of the catalysts for how he got into this in the first place, as you'll hear once we get started talking. And political polarization naturally, maybe not naturally, but draws on our capacities both for rationality and irrationality. So it was a nice way to end up or wrap up the conversation. So you should definitely check out Kevin's Substack, Stranger Apologies, which he populates with all sorts of articles about rationality and irrationality and politics. And you can also go to his website, kevindorst.com, or he's on Twitter at Kevin_Dorst. And reviews, comments, you've heard me say this not quite 107 times so far, but subscribes, likes, all of these things are extremely helpful. You'll see this new Robinson's podcast shirt I'm wearing, aka the Snaky Tee, which can be found on robinsonearhart.com. And I eat my pint of ice cream every morning. Well, lately, I have moved away from morning ice cream since it's the summer. Not that connection would make any sense to you geeslings. But I do that on Twitch and YouTube at Robinson Eats. And now, without any further ado, I hope you enjoy this conversation as much as I enjoyed having it with Kevin. Kevin, your philosophical work, as I've been able to tell, is quite roughly concerned with rationality and irrationality, and more specifically maybe on the gap between normative theories of rationality, so theories that tell us how a rational agent should act, and then descriptive accounts of how irrationally or rationally people actually act. And I've already spoken, like I mentioned a bit earlier, with some psychologists on the show about these topics. And so that makes me particularly curious first about not only how this became your interest in general, but about why philosophy rather than, say, psychology or economics was the route you chose to explore it.
Yeah, definitely. Do you want the long version or the short version of that story? I feel like I got two, but
Long version's good. We have time.
excellent. Uh, so in undergrad I was philosophy, poli-sci, double major, but I also did a bunch of psychology and like bumped into stuff about rationality then a little bit. Like every early psych courses, you learn about the heuristics and biases program, which I'm sure we'll talk more about, which is broadly speaking the thought that when we went and did a bunch of empirical work on judgment decision making, we found that people were systematically really irrational and biased, and they did all these things to entrench their views and get overconfident and all the rest. I sort of got that message in undergrad and just sort of, took it in stride and kept going with it. I wasn't that interested in rationality at the time. In grad school, in philosophy, was interested in philosophy for all sorts of reasons, but actually started in ethics and political theory, but then moved into sort of foundations of rationality stuff in grad school. I just sort of like the methodology of what's called formal epistemology in philosophy, of using, broadly speaking, mathematical methods to think about rational beliefs and how people respond to evidence and what knowledge is, that sort of thing. And spent a lot of time just working on the sort of foundations of rationality stuff, building rational models. I was particularly obsessed with one little piece of the theory of rationality in terms of higher order uncertainty. How can people be uncertain about how uncertain they should be? Do so in a rational way. Was doing that for many years in grad school, and then in 2016, some exciting political stuff happens, and a lot of people, myself included, got very interested in what was going on politically and what was happening with regard to polarization. And so I was just curious about it, started to wonder, A, is there any way in which work on I've been doing can be relevant to anything that's going on with politics, that sort of thing, and B, I had this poli-sci background. I wanted to go back in and think a little bit more about that stuff. And it's just did a deep dive into political science, especially psychology from the 70s, 80s, 90s, about rationality and how we got the view that people are really irrational, and what the empirical data about causes of polarization at the psychological level were, that sort of thing. And basically just found like, whoa, there's philosophy embedded throughout this entire research program. So like, you go to the papers in the 70s, 80s, 90s about ways in which people are irrational, things like the group polarization effect, which was supposed to be a classic, broadly speaking, irrational picture of how groups polarize by they are talk with like-minded others and share information that fits with their prior beliefs in this blah. And if you just read these classic papers, they just sort of shot through with normative language about how this is clearly an irrational response to evidence, or this is a biased way to respond to evidence, that sort of thing. All the while without any explicit models of evidence or rationality. And that's true of some of the literature. Some of the other literature does have explicit models of rationality. This is some of the stuff Kahneman and Tversky, who are the famous heuristics and biases folks, did. And they had very simple normative model. They had what formal epistemologists learn, like formal epistemology 101 or Econ 101, what your models of rationality are. And they were looking at deviations from those models to actual behavior and using that to diagnose empirical irrationality. So I just got curious, well, it's been, a few decades since then. We've got a lot more sophisticated models from a theoretical point of view. We also have done a lot of philosophical, careful thinking about rationality since then, and maybe thinking about some of the same empirical effects with a different, one might say, somewhat biased way, more philosophically informed approach, or just anyways, more critical approach about normative assumptions. What's that going to do for how we interpret this? That's basically how I got into thinking about rationality. There's a lot more to say, but I think that's a version of the long story.
Well, one thing you said that I'd like to hear more about is, what was it specifically about the 2016 political situation that you saw that served as the catalyst for your growing interest in the area?
Yeah, I mean, I could talk about this the whole time. So that's it. I mean, a few things. One, was just a more personal one, which is that I grew up in Missouri in a fairly not super conservative, but a conservative area, a lot of conservative friends growing up. And here I was many years later in graduate school in a super liberal city, Boston, with a bunch of liberal friends. And like me and everyone in my social circles were just completely floored, shocked by no one, despite whatever 538 polls, no one really thought that could happen, that Trump could get elected. And similarly in Brexit a few months before. And there was this moment when I realized that I didn't know anyone who voted for Trump, which was very weird, being someone who grew up in a conservative place and used to have a bunch of conservative friends. The friends I still kept in touch with were all liberal, turned out. And I got very curious, how did that happen? And so that just had a little bit of personal reckoning for me. I mean, it turns out this is part of a broader sociological story of what's called partisan sorting, where basically people have more and more aligned socially with their political views. Talk about that if we like. But that got me thinking, okay, well, what happened? What's going on such that someone like me, who liked to think they're open-minded and listening to all sorts of views, was that surprised by that big chunk of the population having such a different set of views? A related feature was, as everyone does, maybe not everyone, many people do in graduate school, after you're a few years working deep down some theoretical rabbit hole, you're wondering, what's the point of any of this? And part of me was wondering, I've been working on high order probability models of high order uncertainty for years, and every philosopher who writes on these sorts of things says and thinks that it's relevant to, they talk about what do you do in the face of conflicting peer disagreement or evidence that you're not thinking clearly, and they'll give cases that motivate their theorizing that are intuitive, but rarely is it actually brought that much to bear on real world empirical work, how people reason and how actual people think. And so I was curious about whether that more could be done on that front. And yeah, I think in particular what the 2016 revealed was something like you had a ton of polarization, and a lot of the explanations for it were due to misinformation or irrationality, the thought that people are sort of getting into groupthink or herd mentality or whatever. And I mean, having thought for a while about rationality, I just was curious, well, what's the basis of that? I've read these op-eds which say that, but how do they get to that conclusion? So that's a bit of how that sparked.
Mm-hmm. I noticed this political and social alignment a lot with regard to the podcast, in that it's quite difficult to find conservative voices within academia. And there's also a serious social cost to speaking with them, even if speaking with someone clearly doesn't commit you to sharing their views, whoever they are.
Yeah, totally. I think it's one of, what to say here. There's been a ton of social sorting generically in the US, and I think as far as I know, the measures are even higher for things, higher education, for both the number of people who are in a given social group, liberal or conservative, and so on. And there's a sense, and it's hard to know exactly how to quantify the sense, but there's a sense that sort of it's become more difficult to speak on issues from various different points of view, which makes sense insofar as what's happening is something like people are becoming more and more aligned in their viewpoints. It's, maybe this is common knowledge, but the classic example is like 50 years ago, if you knew someone's view on gun rights, you could not predict their view on abortion rights. Now you can. And I think that's true for all sorts of other issues. Of course, these are all things people really care about and care deeply about and have very strong moral opinions about. And so if you find that more and more the people who you talk to all agree with you down the line on, yes, obviously we should restrict gun rights, and obviously we should allow abortion rights, and obviously we should, or pro-trans, like whatever be sort of the down the line of the liberal column, and likewise that should people on the other side down the line in the conservative column, you're going to start to think that people who disagree with you there has to be something wrong with them. Right? There has to be something at least very different in the way they're seeing the world, that starts to lead to less with them mentality. You're sort of interacting with them less, so it's easier to demonize. There's all sorts of stories we can tell about this, and I'm interested in those stories. But yeah, I don't know how far you want to go into that.
Well, before we get to irrationality, where I think a lot of the real fun is, I'd like to go over the classical theories of rationality, which I'm hoping will serve as a sort of foil when we get to our flaws, or maybe more charitably, our often useful but occasionally misleading cognitive leaps and shortcuts. But in particular, I'd like to talk about Bayesian reasoning. And to start, though I know you're not a historian, so this is a very low pressure question, just who was Thomas Bayes?
Yeah, definitely not a historian, and I don't think anyone will think I am. But Bayes was roughly some English guy in the 1700s, I think 1700s, who was a statistician and philosopher and minister, who was interested in questions about probability and statistics, and very often in what's somewhat misleadingly called classical statistics or frequentist statistics. The sorts of problems we're facing is when you know the probability of something, infer how likely various outcomes are. You know a coin is fair, how likely is it you're going to get 3 heads in a row if you toss it 3 times, for example. Bayes was interested in a problem which is sometimes called inverse inference or inverse probability, where you're trying to infer a probability from some data. So instead of knowing the coin's fair, suppose you're unsure whether a coin is fair or slightly biased towards heads, 2/3 biased towards heads. You don't know which. You know, I picked this coin out of a bucket, and in the bucket, half the coins were fair coins and half the coins were biased towards heads. Then I flip it once and you see it lands heads. Question: how much more likely now should you think it is that it's a biased coin? Intuitively, it's some evidence, because after all, biased coins they're biased towards heads, they're more likely to lead to what you saw, namely heads, versus fair coins are. I mean, you can see that easily in the limit. If I toss it 100 times, it lands heads every time. Of course, it's a biased coin. So the question has sort of been given a little bit of data. How can you infer how likely this coin is to land heads given your prior beliefs? And he basically was the first formulation of a way to specify a formula for that, given certain prior beliefs and given various hypotheses for what the coin could be, how biased it could be towards heads or fair. How likely should you think it is biased towards heads after seeing 1 heads or 2 heads or whatever? So that's roughly what he did. And part of the reason why it's so interesting in Bayesian statistics and Bayesian approaches to, well, there are a few stories here. One is that Bayesian approaches to rationality are sort of dominant far and away and have been for much of 20th centuries on. We talk about why that is. Second is different approaches to statistics, and Bayesian statistics in particular have had a resurgence in the last, say, 50, 60, 70 years. Part of the reason is that sort of those inverse inference problems are everywhere. Like once you start looking for them, so like when you see, a job applicant and you're trying to infer, well, how good of an applicant this is, you have to somehow look from the data you've got, like here's their CV or their resume or whatever, to like how likely are they to produce good work or do good work. Or reading a paper, you sort of read the abstract, and from that little bit of data, you're supposed to infer, well, how likely is it that this is going to be a worthwhile read? Or listening to an interview, the first 5 minutes, you're like, well, that guy was really eloquent, or that guy looks like an idiot, or whatever. That you're trying to infer how likely it is that it's going to be worth. I mean, I'm stretching it a little bit, but that's the sort of structure of many problems that have this sort of similar pattern to the coin problem. That's part of why Bayesian reasoning inference is so pervasive and important.
And so I know you just taught a course on rationality in which the first half of the semester was entirely devoted to Bayesian reasoning. So in a portion of a single conversation, we're obviously not going to cover all of it, but are there any general pillars or tenets of Bayesian reasoning that are easily expressible in conversational format like this?
Yeah, I think that's right. I'm going to say some things that are obvious and some things that are a little bit more controversial, maybe, what should be thought as tenets. I mean, the basic picture is we can represent sort of degrees of belief or uncertainty with probabilities, which people might be familiar with from basic stats class, which are basically numbers between 0 and 1 or between 0 and 100% that have some structural features. Thought is 100% represents certainty, like 100% confident the coin's going to land heads, it's definitely going to land heads. 0% is certainty and negation, or certainty that it's false. So if you're 0% confident it's going to land heads, then it's definitely not going to land heads. It's definitely going to land tails, and 50% is middling, and so on. And the first thought of Bayesian reasoning is we can represent someone's state of uncertainty when they're uncertain what the world's like with a probability or maybe a set of probability distributions. And the second thought is that there's a certain principled method for updating those probability distributions, for responding to new evidence. That's what the inverse inference case is supposed to make you think about. And roughly the thought is, in a slogan, things are evidence for things that make them likely. So when you're unsure which hypothesis is true, or what the state of the world is, and you get some new data, that data supports a hypothesis that should lead you to expect that data, which is somewhat almost obvious when you say it. But in the coin case, for example, why is it that seeing a heads is evidence that the coin is biased towards heads? It couldn't be. A fair coin leads to heads half the time, right? So why is heads evidence for it being biased? Well, the reason is a fair coin leads to heads half the time. A biased coin leads to heads more than half the time, 2/3 of the time, if I set it up that way. And so since you should more expect the evidence given that it's biased, more expect heads given that it's biased, you should increase your degree of belief or probability that it's biased when you see heads. And those are some of the basic pillars. I think they can feel and sometimes get presented as sort of axioms that come a bit out of thin air sometimes. I mean, most of the reason, I think two classes of reasons for why people like Bayesianism and also are related to what sort of guiding thought behind it is. One is just that it sort of is very useful for thinking about problems and cases of uncertainty all the time. Just like in practice, when people are trying to reason through situations of uncertainty, very often writing up a little Bayesian model and thinking about what is evidence for what is very clarifying. If you do it enough, you start to see, this is a very helpful way to view the world. A second is that there are a bunch of theorems or arguments that are given in favor of Bayesianism that have broadly speaking, the structure that, given some minimal assumptions, you have to act and believe in a broadly Bayesian way if you're going to act in ways that are expected to lead to good outcomes, more or less. So the thought is if you violate Dutch book arguments, for example, that if you violate Bayesian constraints, you can take a series of bets that are guaranteed to lose you money. You can see beforehand they're going to lose you money. No one should do that, at least if they like money. And so those are the sorts of arguments people point to, that like Bayesianism is really a way of formalizing or making precise the thought that rationality should help you get what you want, should help you figure out how to navigate the world and infer what's true, and should make actions that are effective given the way the world is. So we can talk more about it if you like. That's sort of some of the motivating thoughts behind both pieces of Bayesianism and thoughts behind it.
No, this is all extraordinarily interesting and great. And so it's actually like the first time that Bayesian reasoning has come up on the podcast in detail. So I'm really happy to be talking about it. But something you said is that things are evidence for things that make them likely. And the 100 coin tosses all heads up is likely to make true the hypothesis that the coin is biased. But multiple hypotheses can make, or the same data can make multiple hypotheses true. So in this case, the coin could be fair, but maybe there's a wizard affecting the coin. And I'm wondering if there's a general principle for selecting which hypothesis among competing hypotheses we ought to give the highest credence to, or is this a case where new evidence just affects the distribution of probabilities to different hypotheses, or how you look at this?
Yeah, so let me see if this answers the question. I think probably getting at a point that Bayesians love their simple examples where it's easy to specify beforehand what the possible hypotheses are. I said, for example, I've got a bucket full of coins, half are fair and half are biased. I'd like nicely constrains your hypothesis space or sample space in the Bayesian terminology. There's only two. There are no wizards about. A fair coin leads to heads half the time, that sort of thing. And of course, in those cases, it's very easy to write down Bayesian models and solve them, or say what the correct or rational or Bayesian answer is. In most real world cases, it's not like that. In most real world cases, sort of you have to do some there's an art of judgment of figuring out what the relevant likely hypotheses are, and how likely sometimes it's not even clear, given hypothesis, how likely it makes things. You have to do, I gave you a case where the hypotheses about like biases of coins, which like are pretty clear. Like fair coin seems to be, okay, 50% likely to land heads. 2/3 biased coin, okay, 2/3 likely to land heads. But if I just said biased, if I hadn't said 2/3 biased, I just said half the coins are biased. Well, now there's some judgment, like how biased are coins on average? If it's a biased coin, is that going to be like 60% biased or 90% biased, whatever? Sort of, as soon as you start formulating more general hypotheses, it gets hard to say both what the likely ones are and what are called the likelihoods in Bayesian terminology, how likely data is given those hypotheses. And I think the short answer is there is no short answer. There's no quick and dirty answer for what those hypotheses should be in any given case, or exactly how given what they are and given your prior beliefs about them, there is an answer for how you should respond to data. But I think this is where what sometimes it's called the specter of subjectivism comes into Bayesianism, where sort of Bayesianism gives very strong constraints given certain prior beliefs and given certain evidence how you should respond. Those prior beliefs will include opinions about what the relevant hypotheses are, whether there's a wizard about what have you. But it doesn't tell you that much about what the reasonable prior beliefs should be, for example, and what the relevant alternative hypotheses are. And that some people say, well, since we can't write down any formula that tells us what they should be, we should be radical subjectivists. We should say, well, any prior beliefs that are consistent in the sense of obeying the probability axioms and so on are perfectly rational starting points. Other people want to constrain that in some more or less principled way. A lot of people, myself included, think, look, we've got an intuitive notion of what reasonable starting points are that we are sensitive to all the time. Sort of, no one needs a theorem to tell them that if someone walks into this, if you right now are extremely certain that there's an elephant in my office, everyone knows that you're unreasonable, right? And you don't need to write down a theorem that says why that's so. It's just because, well, something like, given what you know about the world, it's hard to see elephants in offices and things like that. And if you're happy to take some of those intuitive judgments for granted, that there are facts about what's rational. And Bayesianism is a model that sort of constrains and helps us make further inferences about what's rational, given certain assumptions about starting points that are rational, that we can sort of wave our hands at what's sometimes called the problem of subjectivism or prior. I don't know how much that answered the question, so feel free to follow up.
No, it does, and that's very helpful. So there are, I think you mentioned two tenets. Maybe there's a third one mixed in there somewhere, but we can represent degrees of belief or uncertainty as probability, and then there is a method for updating these probabilities with new evidence. And I'm wondering just why, and maybe this is a very softball question, but I just like to get it out there. Why do you, or why ought we, take Bayesian reasoning as emblematic of rationality or rational thought?
Yeah, I don't think it's a softball question. I think it's a hard question.
Okay.
Two answers, I think. Maybe one answer. The broad answer is under a lot of assumptions about the connection between beliefs and action, under very minimal assumption connection between action. Broadly speaking, Bayesian agents will do better than non-Bayesian agents, given the same prior beliefs and same links to action. So one way to put it is what are sometimes called, I think, value of rationality style arguments that says, look, whatever else rationality should be, it should be something that helps guide your decisions and helps lead to better beliefs. And a lot of the arguments for Bayesianism can be seen as basically ways of making precise the idea that if someone's a non-Bayesian, then they will be beaten out by Bayesians who have the same resources that they do. And so there's sort of optimality style justification for Bayesianism. And this is actually one of the reasons why cognitive scientists, and we'll probably get this later, some of them love Bayesianism as this sort of, it gives you sort of this upper bound that you can see things approximating and maybe doing better by getting close to. I think that's sort of what a lot of people say of the guiding thought. Now, of course, any such argument, especially if it's precise, is going to have precise assumptions about how we're representing beliefs and what the links are between beliefs and action and what the alternative ways, what alternative non-Bayesian ways of updating your beliefs are. And all those will have controversial philosophical assumptions built in. And so there are ways of varying Bayesianism that keep some of the basic ideas, but change some of the components. So it's sort of representing you with a single probability function. There are some reasons why people want to represent you with a set of probability functions or allow for imprecision or vagueness in your probabilities. Likewise, instead of updating in the standard way, which is sometimes called conditioning, philosophers sometimes call it conditionalization. That's actually what it's called a back formation, because the verb is conditioned, and from that people form the... It's not important, but conditioning is the updating procedure. And there are variants of that which allow for updating based on evidence that's hard to specify or ambiguous, for example. Maybe we don't want to go into the details there. But so there are variants of Bayesianism. I think those are also the theoretical arguments. I think one of the... If you just ask the sociological question, why are most people thinking about rationality using Bayesianism as the standard? I think it's just because it has no real competitor as far as in terms of breadth of application, in terms of sort of levels of insight it brings and to problems, and in terms of flexibility. And so there are other ways to represent beliefs. You just represent outright beliefs without representing degrees of belief. You can represent degrees of beliefs with other functions, like Dempster-Schaeffer functions, for example, alternative models. And there are other ways of connecting belief to action besides the way Bayesians standardly do. And all those can work, and philosophers explore them, and some cognitive computer scientists explore them and that sort of thing. But I think as a matter of practice, when people are thinking through real world problems, Bayesianism is very useful and brings a lot of insight, and these other ones sometimes do, but I think there's a reason why it's the consensus view based on sort of that's hard to articulate with a precise argument. It has to do with the way it's used in applications and how people find it.
And is the very rough and very oversimplified idea that specific questions of theory and representation aside, rationality in this context is forming and updating our credences in a principled way based on evidence and new evidence? You think that's a fair way of saying it?
I think that's right. So maybe it's worth introducing what philosophers call a distinction between types of rationality, sometimes called practical rationality versus epistemic rationality. Practical rationality is supposed to be like acting well to serve your goals, whatever those might be, whereas epistemic rationality is somehow conforming your beliefs well to get knowledge or have accurate beliefs that people vary a little bit how they gloss it. Bayesianism sort of is a theory of both to some degree. So on the epistemic side, it's what we've been talking about. Epistemic rationality is sort of, according to Bayesianism, broadly speaking, modeled with having the right sort of coherence to your beliefs. That's the probabilistic component. And responding to evidence in the right way, that's the conditioning component. And so, yes, that is, broadly speaking, how they're thinking of rationality. On the practical side, then there's linking beliefs to action. So when you're, unsure whether the coin's fair or biased, is a question of like, what should you bet on? If you're forced to bet on which coin it is, or if you're forced to bet on how it's going to land on the next toss or something like that, how should you act? And Bayesianism will have a principle called maximizing expected utility that tells you how to make your decisions based on what you value and what your beliefs currently are. And that's the theory of practical rationality side of things. And I think that, so broadly speaking, that's right. Sort of, there's a way in which maybe it's worth emphasizing that a lot of the arguments for Bayesianism are practical arguments, the way I was glossing it as sort of you're going to accept bets that lead to a loss. You're going to make worse decisions by your own lights if you violate Bayesianism, that sort of thing. So there's a way in which sort of, although at its core, Bayesianism, the theory of epistemic rationality, is a bit justified by the thought that, well, whatever else epistemic rationality should be, it can't just be an arbitrary list of principles. It's got to be something that helps you navigate the world. So if some philosopher came down and said, here's my theory of rationality, and someone pointed out, wait a minute, if I follow that theory, I'm going to accept a bunch of bad bets. I'm going to make a bunch of bad investments. I'm going to lose all my friends. Why should I follow it? The philosopher should feel awkward, right? And I think Bayesian has been sort of motivated by the thought that, rationality is something like doing the best you can given the information you have to get what you want, or get what you value, get what you should value. And that's sort of what Bayesian is trying to make precise.
Well, I think this has been extraordinarily useful and helpful in getting us toward the specifics that I wanted to move to. But before we turn to them, I just had one last question about this. And you've written that these sorts of classical theories are elegant, useful, and wrong. And as far as elegance is concerned, I assume you mean that they're parsimonious and technically slick, and then that they're useful in that they tell us how we ought to reason, and they're wrong in that they don't often match up with our actual behavior. But are there other ways in which you meant that they're elegant, useful, and wrong? Because I think this is really important. So I want to make sure we've covered the gamut.
Good. So I think I actually did it wrong in a slightly different sense. It's interesting that you interpret it that way. So elegant and useful, yes, sort of theoretically parsimonious, useful, they're widely applicable and make sense of a lot of cases. Wrong, they're certainly wrong in the empirical sense that they often don't predict behavior. But I meant more controversially in the normative sense that they often, standard Bayesianism, the sort of picture that I've been glossing, is a highly simplified model that breaks down in lots of cases. And it's interesting to look at the cases in which it breaks down and sort of see how it should be generalized. Now, I still think it depends a little bit on what we mean by the standard theories, but I still count myself a Bayesian, even though I think a lot of I like to use a class of models that is much broader than what most people would recognize as, those are the Bayesian models. So the ways in which it's, take classical Bayesianism to be what I said at the beginning. Your beliefs are probabilities represented by a single probability function, and they always update by conditioning. And actually, this is a little bit technical, but when people say beliefs always update by conditioning, what they always implicitly mean, unless they say otherwise, is updating by conditioning on the true cell partition. So a partition is a way of dividing up logical space such that it doesn't really matter. It's a particular way of dividing up the possible bits of evidence you might get. And Bayesianism in practice always involves updating on evidence of a particular structure. Sorry, I shouldn't say always. I should say when people just refer to Bayesianism in the abstract, certainly when they apply it in social sciences, that's what they mean. Call that standard Bayesianism. Probabilism, probabilities represent your beliefs plus you condition on the true cell partition. That has a lot of surprising consequences, and not just surprising, but actually consequences that you might think show it's a little bit too strict or wrong as even a theory of ideal rationality. So let's mention two. One is that it requires your opinions to be perfectly precise in the sense that you should have a complete ranking of how likely any two claims are. So Kevin, here are two claims that you might be uncertain about. I own at least 14 pairs of socks. That's claim one. Claim two is hippos on average weigh above 800 pounds. So those are two random claims. I just made those up. Which is more likely, given your evidence now?
I really have a bad sense of what hippos weigh. I was thinking like if your mom is anything like mine, you have way more than 14 pairs of socks. So that's the one that I want to say is more likely.
Good. So then now let's vary the case. So, all right, now 13 pairs of socks. Now 12 pairs of socks. Or sorry, 15 pairs of socks. Whatever. You start with the one that you think is more likely and slowly change the claims. Right? Bayesianism, standard Bayesianism entails that initially, say you're more confident that I have at least 14 pairs of socks than hippos are at least 800 pounds, whatever I said. Then what about 15? What about 16? What about n for various n's? Bayesian says there's an n such that you can say exactly what it is, such that at n minus 1, you're more confident of at least that many socks than hippos at least 800 pounds, and at n, you're less confident, or at most as confident. You have complete comparability, and you can, moreover, implicitly, you can introspect those comparisons. You know exactly what they are. This is basically a consequence of any probability function generates a complete ranking. And if the probability function doesn't have higher order uncertainty, then it knows what its own ranking is. And you might just think that's a pretty strong sort of, it seems like it's imposing that people have, you might think, more opinions than they should, or more precise opinions than they should.
Yeah, we're running into a vagueness, Sorites sort of problem.
Exactly, yeah. So you might think it's, one question is whether this is simply an artifact of vagueness more generally. Maybe this is just the paradox of the heap, where you start with, one grain of sand is not a heap, but add a grain, well, I can't make it a heap, and we're off to the races. Now, a million grains of sand is not a heap. So you might think that's the issue here. And there's some back and forth, we get into it about why that is. But basic concern is that these are very precise models, and the precision is showing up in opinion, how rich your opinions need to be to satisfy standard Bayesianism. And so some people think that's one of the motivations, for example, for using sets of probability functions to represent your beliefs rather than a single probability function. If you use sets, then there can be some vagueness or incomparabilities between how likely you think various claims are. That's one way to think Bayesianism might be wrong, it might be overly precise. Another way, and one dear to my heart, is that if you take the standard Bayesian picture of you have a single prior probability function, you always update by conditioning on a partition, that entails that your opinions are introspective, in the sense that when you update on new evidence, you always know exactly what that evidence was and what your opinion should do in response to it. So effectively, that's because people know what a partition is. You always know which cell of the partition you're in, and therefore know how your beliefs should update. The concrete case is when you flip a coin, it either lands heads or tails. And you don't know what the bias of the coin is, but you know how it landed, right? You know exactly what your evidence was. It was heads. And if someone asks you what your evidence is, you'd be able to tell heads, definitely. But many of our cases aren't like that, right? Well, here's a question. How many leaves are on this tree? And then you get a quick glance and then pulled away. So it's hard to specify exactly what your evidence was. I don't know. There were definitely at least 20, definitely less than 5,000. It's hard to specify some particular number that it seemed like there were, any particular number. And sort of, it's hard to fully capture exactly what you saw and know exactly what your evidence was. And this is one of the cases in which many people think that we should think of Bayesian models that allow for your evidence to be somewhat ambiguous or imprecise in some way. And basically, you just can't model that. Controversial claim. You can't model that using the standard Bayesian tools. And if you do model it, you're going to get some different structural features. So those are two of the maybe long-winded ways in which I think those standard Bayesian models can be, let's say, overly simplified. I said wrong for rhetorical effect. But yeah.
Well, just to very quickly paraphrase for my audience that isn't familiar with the philosophical normativity jargon, you say that standard Bayesian reasoning is wrong in the normative sense, in that Bayesianism is not always the way we ought to reason, or it's not somewhat oxymoronically the rational way to reason in order to get the best outcome in certain problem cases.
Yes, I think that's a nice way to put it. So if you think sometimes your opinions should be rationally imprecise, or sometimes you should respond to evidence that's ambiguous and should acknowledge this ambiguity, that you can't model that with Bayesianism. And so that's the way in which we maybe want to enrich our models and make a broader class of Bayesian models that can.
Okay, great. And without any further ado, I think I'm now ready to turn to human irrationality. And I think in doing so, we ought to take a look at just an assortment of topics that might be illustrative of the same. And hopefully we can keep in mind both the psychological dimension of irrationality on the one hand and the philosophical, these two different approaches, to see maybe how they both contribute to our understanding of the phenomenon. But, well, yeah, so wherever these come up, maybe we can just discuss them. But for now, let's start with the hindsight bias, which hasn't come up on the show yet. So what is the hindsight bias?
Great. So the hindsight bias is one of these, I think 200 plus cognitive biases that have been empirically documented by the Heuristics and Biases program, which basically was looking at ways in which people seem to be doing reasoning in non-Bayesian or non-rational ways. Hindsight bias, there are a few different versions of it. Here's a version that's, I think, easy to work through. It's the bias that when you learn that something happened that affects your interpretation of evidence, and in particular, you think the evidence made it more likely than you initially thought. So the classic study runs like this. It says we give some people come in a psych lab and we give them, here's some evidence about whether a train is going to derail. We give some list of, here are these experts that sort of been investigated and looked at the train, and here's what their report said, and here's how often train derailments happen, and blah, 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 blah. Please estimate, how likely this evidence makes it that train X is going to derail next week, whatever. People give some numbers. Different conditions, sometimes same subjects later, sometimes different subjects, give the exact same evidence. These experts looked at the train and they said X, Y, Z, here's how often trains crash, etc. By the way, train X crashed last week. How likely did this evidence we gave you make it that train X was going to crash? What we're asking is how predictable was it given the evidence? And the hindsight bias effect is that the people who answer that question give a higher number than the people who answered the first question. The people who answer the first question give it just the evidence and not told whether the train crashes will estimate the likelihood, maybe 1%. Then people who are told, the train did crash will then look at the exact same evidence and say, someone who was looking at that evidence should have said 5%, or whatever it was. I wasn't thinking about this, but this is obvious. We're recording this right after a massive train crash in India, tragic. And one of the things people ask is, well, how predictable was this? Was this something that we could have seen coming? And that's the sort of thing people obviously care deeply about. And the hindsight bias is the concern that people's judgments in that context are biased. They're biased by their knowledge that the thing actually happened. And so maybe they're going to give unfair predictions about how predictable it was. This is sometimes called the I knew it all along effect, because, of course, if X happened, then, well, it must have been predictable given the evidence. That's the effect.
And I'm wondering if this is a case where Bayesianism does help us or doesn't help us, or where you want to use a different sort of model to suggest how we ought to be reasoning in these cases?
Yeah, so I think Bayesianism, let me be clear. Bayesianism always helps, but sometimes you have to pick your brand of Bayesianism to help. And this one we can use standard Bayesianism to get an intuition, and we have to make some subtle adjustments to actually help in this case. The basic observation, and this is due to Brian Hedden makes this nice. So I'm basing this on a nice paper Brian Hedden wrote called Hindsight Bias and Not a Bias. who's a philosopher at ANU. No, basic point, first consider this different case where you don't know what evidence I have. Let's take a different train case. You're wondering, how much evidence do I have that it's going to rain in Boston tomorrow? Right? You don't know how likely I should think it is that it's going to rain in Boston tomorrow. I'm in Boston. Then you learn on your phone app says it is going to rain in Boston tomorrow, definitely, 100%. Now all of a sudden you should think, oh, it's much more likely that Kevin had evidence that it was going to rain in Boston tomorrow. After all, since you now know it's going to rain in Boston tomorrow, well, Kevin probably checked the weather apps. And so it's more likely that he had evidence that was going to support that claim that it's going to rain tomorrow. Does that make sense? The intuitive why that would work? And that's basically, one way to put it is, suppose you didn't know it was going to rain tomorrow in Boston. Conditional on me having evidence it's going to rain tomorrow, it's more likely to rain tomorrow. You sort of think, well, I don't know about what's going on in Boston, but if Kevin has good evidence it's going to rain tomorrow, it's probably because the weather app said it's going to rain tomorrow, in which case it's probably going to rain tomorrow. So the hypothesis, Kevin has evidence it's going to rain tomorrow, makes it likely it's going to rain tomorrow. What Bayesianism gives us, and which is not obvious, is that the relation A is evidence for B is symmetric. So if A is evidence for B, then B is evidence for A. That's exactly why that is. Remember, Bayesianism said things are evidence for things that make them likely. Right? So take the coin case. Why is it that heads is evidence for the coin's bias towards heads? Well, because the coin is biased towards heads is evidence that it's going to land heads. Sorry, if you didn't know it was going to land heads beforehand, then you learned the coin's biased towards heads. That makes you think it's more likely it's going to land heads. Likewise, you see it land heads, that makes it more likely because of that. When you see it land heads, it makes it more likely it's biased towards heads. So basically, evidence is about correlations, and correlations are symmetric. A is correlated with B, B is correlated with A. So taking that back to the rain case, the obvious fact is that if I have evidence for rain, that makes it more likely it's going to rain. Flipping that by symmetry, that means if it's going to rain, it makes it more likely, other things equal, that I have evidence it's going to rain. Because those states, it rains and Kevin has evidence it rains, are correlated. That's what it means for them to be evidentially valid to each other. Okay, so that's all standard Bayesian, that's all a toy case. Let's port it now back to hindsight bias. The basic Brian Hedden thought is that the case is exactly the same. It's that at a first pass, and we can go into why we need to complicate Bayesianism to make this work in a minute, but at first pass, the idea is this. I give you some evidence about the train, whether the train's going to crash tomorrow. Call that evidence E. And it's like, the list of expert opinions, the list of these base rates and that sort of thing. It's complicated evidence. You know exactly what E is. You know exactly what evidence I gave you. But still, you reasonably might have some uncertainty. You might have some, as I would say, higher order uncertainty about how uncertain that evidence should make you about the train crash. You're not like completely certain, yes, given this evidence, I should be exactly 72% confident it's going to crash, or 5% confident it's going to crash. You should give some uncertainty. I don't know exactly how confident to be given this evidence. The various hypotheses you can entertain, maybe it's strong evidence, maybe it's weak evidence, maybe it's somewhere in the middle. And what's definitely true, you're uncertain what to make of this evidence. But if it's strong evidence, that provides, conditional on being strong evidence that train's going to crash tomorrow, you should think it's more likely the train's going to crash tomorrow. Just like conditional on me having evidence it's going to rain tomorrow, you should think it's going to rain tomorrow. So likewise, by symmetry, conditional on the train crashing tomorrow, that's some evidence that it was more likely than you thought that they're going to crash. So if effectively what's going on, just as you're initially uncertain what my evidence is, and you get evidence about that by learning what happens, it rains tomorrow. Likewise, you're initially uncertain about how strong your own evidence is, and you get evidence about how strong it was by seeing, the train did crash. Maybe I should have interpreted that as stronger evidence than I did. So that's the basic Brian Hedden thought. And there's probably more in the weeds there than we wanted to go. But the intuitive thought is that when you have uncertainty about how to interpret your evidence, hindsight bias is often rational. The reason being, learning what happens provides some indication of how you should interpret your evidence. And maybe, for example, if you had a very low interpretation, you thought it was very unlikely to happen, and it does happen, that suggests you messed something up. So it suggests you got something wrong.
No, that's exactly where I wanted to get to, in the sense that there are times when bias can be, even though bias has negative connotations, there are times when it can be a good thing and useful. And that's probably why, to some degree, our cognition involved to rely on them in certain cases.
Yeah, I think that's some of the motivating thought behind papers like Brian's, arguing that, look, we can make some rational sense of this sort of structural feature that has been labeled a hindsight bias. Now, there's a whole bunch of other follow-up questions to ask. One is like, is it right that that's actually what's going on in these cases? That this is, actually driven by this sort of Bayesian reasoning under the hood. People obviously aren't explicitly reasoning that way. The question is whether that's somehow driving their judgments subpersonally or implicitly. There's also questions about degrees. Like, well, is this actually, is the degree of hindsight bias that people exhibit actually appropriate given this sort of normative justification of when it can sometimes make sense? And those are obviously hard follow-up questions to ask. There's obviously, there's a sense of bias where it's just a, non-normative empirical fact. There's just this tendency people have, question what drives it. Then there's the pejorative sense where you say, it's a bias in the sense that it's irrational. And this sort of obviously plays on those two senses, but it leaves open what normative conclusions we end up drawing from that. So.
And forgive me, I probably should have asked this. Well, I mean, it's not that it's instrumental or necessary for the conversation, but it's important. And maybe I should have asked this a few minutes ago, but in addition to your course on rationality, you also just co-taught a course with Roger White at MIT on the epistemology of controversy. And in it, I think you addressed just what a bias is. And since beyond the hindsight bias, we'll probably touch on a few more of them, even if we don't use that name to describe them. How do you look at bias, or define it maybe from a philosophical perspective?
Yeah, I mean, this is one of the things that we certainly worked on in the course, but I don't think we got to the bottom of. So I think,
As with all and there's rarely a quick answer to these sorts of things. So my question presupposes maybe that there is, when I'm sure there's hundreds of papers just arguing this question.
Well, I can give you a few quick answers, and we can talk about this. So, one notion of bias is just deviation from some normative standard. And maybe some genuine normative standard. And that's a very simple, intuitive one that says, look, whatever the right standard is, a bias is a deviation from that. So the classic, in this conversation, this normative standard we've been talking about is Bayesianism. So bias would just be any time you deviate from whatever the Bayesian version of yourself would do. Another version, which I think, that version obviously builds in that bias is, it's a pejorative. So the bias is a non-normative, is irrational. Another notion of bias, which I think is interesting, and we can sort of point to as, maybe two more. Two more notions of bias that come up a lot, or at least one comes up a lot, another should come up a lot, that don't necessarily have the normative presupposition. There's a notion of bias from statistics called when is an estimator biased? When is a statistical estimator, which is a way of forming an estimate of a quantity in response to data, biased? Interestingly, in that sense, Bayesian inference is statistically biased. The reason is that a biased estimator is one which, conditional on the value of a variable being x, the expectation for what the estimator will be is not necessarily x. For example, I'm pulling a coin. We love coins of unknown bias. All Bayesians love coins of unknown bias. They're very easy to think through. So I got a coin. It's got some unknown bias between 0 and 100% bias towards tails. You don't know what. You're going to flip it a few times and then form a belief about how likely it is biased towards, an estimate of how biased it is. And you're Bayesian. If you start out with like a flat prior over how likely it is to be biased, like, well, it could be any bias between 0 and 100% and equally likely. Then sort of the average of that is right in the middle, 50%, right? That's your prior estimate for how biased it is. And when you get data, it's going to be a way of revising that prior, but you're not going to completely, defer to the data. If it lands heads twice in a row, well, then of the data you've seen, it's landed heads 100% of the time. But you're not going to have your estimate for the bias of the heads at 100%. You're not going to think, okay, well, the next time it's definitely going to land heads, right? You're going to have some caution. You're going to start out 50%, you see two heads, well, maybe you go to like 70 or 80%, likely it's going to land heads next toss. That's a bias in the statistical sense because your priors are biasing your estimate. If you came in and you had very different priors, if you were, for example, very convinced that it was heads biased, then seeing two heads, you'd have a much higher estimate, right? And so that's the one way in which prior beliefs are sometimes, in the statistical sense, sources of bias. And this is when statisticians and cognitive scientists talk about things like the bias variance trade-off and various other forms, very often bias gets used in that sort of just technical sense of letting your prior beliefs skew how you interpret data, what conclusions you draw from data. And that's one sense of bias, which, if we think Bayesianism is a good norm of standards, we think, yeah, you should be biased in that sense, because at least you should be biased by reasonable priors. A final sentence, and it's probably more sense than you want, is bias, I'll put this, as selective sensitivity to information. So one way, imagine you started out in the coin case where you're unsure the bias between 0 and 1. You start out at 50%. And I tell you, look, I'm not going to tell you what's going to happen, but here's how you're, I'm going to do something. I'm going to knock you on the head or give you a pill or give some confusing system, whatever it is I'm going to do. I'm going to somewhat confuse you. And here's what's going to happen afterwards. Either you're going to be convinced it's biased towards heads, or you're going to still be 50-50 on whether it's biased towards heads. So you're starting out 50-50 and you're going to end up, after some weird process, maybe hypnosis, maybe pills, maybe whatever, either 50-50 or 100% bias. Notice that there's an asymmetry there, right? Your opinion either moves up a lot towards 100% or stays exactly where it is. On average, therefore, it shifts. One way to put it is, if you get information that suggests its bias, you move your opinion a lot. If you get information that doesn't suggest its bias, you don't move your opinion at all. So you're selectively sensitive. You're more sensitive when you get evidence in favor than when you get evidence against. In fact, you're not sensitive at all when you get evidence against, in this case. And that's another sense of bias, which on standard ways of setting it up, the Bayesian methods are not biased, or rather, standard Bayesian models are not biased in that sense. Even though they're biased by their priors in some sense, the bias doesn't show up in the averages. On average, they're unbiased in a sense. But you might think, that's an interesting notion. It's not standard Bayesian. Part of why I'm interested is that there are alternative Bayesian models that do allow it. Maybe we can talk about those eventually. So there's a question of whether that sort of bias, the selective sensitivity bias, could be rational or normative or not. Obviously, there's an intuitive sense in which, when we talk about intuitive things like confirmation bias, being part of what we have in mind is something like being selectively sensitive to information that fits with your prior beliefs. And so there's a question. That's a notion. We can ask whether it's rational or normative.
There are two more fallacies that I wanted to get to, or biases. And the first is the gambler's fallacy, which is another one that hasn't come up on the show.
Good. So this is one that's close to my heart in the part because I wrote a blog post about this years ago and finally writing a paper version of this now. So it's very much on my mind.
Okay, great.
The gambler's fallacy is the finding that people tend to expect random processes to switch. So if I'm flipping a fair coin, and it's landed heads, and heads again, and heads again, remember there's a fair going, so there's not bias towards heads, you know that. Then people start to think tails is due, right? It's about time. After all, something like fair coins land heads half the time. We've got a series of land tails half the time. We've got a series of heads in a row, so it's about time we got a tails. That's the basic ins and outs of the empirical finding, but roughly, I mean, it varies a lot based on exactly what the causal mechanism is, whether it's a coin or drawing balls from an urn or a lottery number, what have you. But generically, some fraction of people, some non-trivial, fairly significant fraction of people, to a non-trivial degree, expect after a run, which is a sequence of all heads in a row or all tails in a row, that a switch to, if it's all heads to tails or if it's all tails to heads, is more likely after that. The reason why it's sometimes called a fallacy is that if it's a fair coin, then what that means is that the tosses are statistically independent, which means that how it lands on the next toss is not at all affected by how it landed on previous tosses. So a particular fair coin is classically defined as just one that has a 50% chance of landing heads, no matter how it's landed in the past. Coins have no memory, as it said. And so if it lands heads half the time, it has to be each toss, it's 50% likely to land heads. I think that's the basic finding of what the gambler's fallacy is and why you might think it's a fallacy. If you know the coin's fair, you should not expect it to switch after seeing a series.
Well, your gloss on the fallacy that people expect random processes to switch, I've never heard it put that way, and it's really quick and pithy and forceful, I think. But where does the fallacy then enter this paper that you mentioned that you're writing?
Good. So yeah, maybe this is the dangers of talking about things that you're actively researching, and we're probably less clear about how to pitch it right now. But so if we think of the fallacy as something like, given a process that's in fact fair, like a coin, we in fact observe that many people who've seen a lot of coin tosses expect it to switch. And the question of, well, is that a fallacy? Do we have reason to think that they're doing something irrational given that? Of course, if someone knows that a coin is fair in the statistical sense, then of course they should not commit the gambler's fallacy. That's just what it means by definition. And once you see that, you basically think, well, no one clear-eyedly both thinks this is definitely fair and knows what that means, and thinks it's more likely to switch after seeing a series of heads. And so the question really is something like, for people who've seen a bunch of coin tosses and sort of know a bit about coins, or in some sense maybe in a position to know that it's fair, they have enough evidence that they should treat it as fair, it seems like. Could it be rational to, or fallacy that it's not rational to, expect it to switch after a series of heads? The paper I'm writing and the blog post I wrote a while ago was basically how under conditions of uncertainty about the causal process, a lot of the time we should expect reasonable people who are basically updating on a limited amount of data to expect coins to commit the gambler's fallacy or gambler's reasoning, to expect them to switch after a series of heads. The basic reasoning, I'll give you the basic and you could ask whether we want to go into more detail, is suppose, ignore coins for a second. Suppose I tell you I've got this process which lands heads 50%. I got a little bit of code on my computer which either outputs heads or tails whenever you press the button, and half the time in the long run it says heads. Given that, you shouldn't be certain that the tosses are independent, right? It could be that at each time you press the button, there's a 50% chance of landing heads. But it could also be a switchy process, one that when it lands heads or heads on a series of tosses is more likely to land tails on the next toss. And like vice versa, when it lands tails is more likely to land heads on the next toss. As long as those are symmetric, that's going to balance out to 50% on average. And so that's a switchy hypothesis. Another hypothesis is that it's sticky, which is that it tends to stick with how it's landed. Right, so if it lands heads on one toss, it's more likely to land heads on the next toss, and if it lands tails on one toss, it's more likely to land tails on the next toss. It's more likely to have long runs, or whatever. So those are three different processes that would give rise to in the long run 50% heads, either independent tosses or switchy or sticky. Good on that so far?
Yeah. So if we don't, I mean, just moving it back to coin. I mean, maybe you want to keep it abstracted from coins, but if we don't know about the coins and we just observe that it's roughly half heads and half tails, we don't know if it's because the coin isn't biased. There might be some other underlying mechanism, and it's not random, but it just tends to even out at 50-50.
That's right. And there are plenty of, in fact, most causal processes are not exactly independent. So an example of a switchy process is a deck of cards. Whenever you draw cards, either red or black, but if you're drawing cards, you draw a series of red cards in a row. Black card is more likely because now there are fewer cards left.
But when you finish the deck, it's going to be 50-50 in the end.
That's right. So that is called a hypergeometric distribution. You're drawing from a urn without replacement. Other processes are sticky in the sense that when it lands one way, or when one thing happens, it tends to happen again. So the weather is sticky. When it rains one day, it's more likely to rain the next day. When it's sunny one day, it's more likely to be sunny the next day. So these are like perfectly legitimate causal processes that many things obey. And the idea is, well, imagine you started uncertain which one coins obey. Let's go back to coins. So you're unsure whether they are switchy or independent or sticky. Then suppose, what do you know about coins? Well, here's the thing everybody knows about coins. They tend to land heads around half the time. Right? Turns out, for some reason, that claim actually makes... Oh, sorry. Back up one second. You're uncertain whether they are switchy, independent, or sticky. So if you're a Bayesian, and this is something, piece of Bayesian that we haven't, it's been implicit, we haven't really talked about, is that your opinion should be sort of an average of what it would be conditional on those three hypotheses. So if you're really sure it was switchy, then you should expect it to switch. If you're really sure it was sticky, you should expect it to stick. If you're really sure it was independent, you should be 50% each time. If you're uncertain, you should sort of average those things out. And if you're uniformly uncertain between the two, you should be 50%. Confidence going to switch. What happens when you get some new evidence? What happens when you get some evidence which skews your opinions about switchy and sticky? Well, if you get a bunch of evidence for switchy, then that should make you expect it to switch, right? Because after all, we just said, if you were sure it was switchy, you should be really confident it's going to switch. If you're averaging between switchy, sticky, and 50%, then if your average is skewed towards thinking it's switchy, then you should be a little bit inclined to think it's going to switch. Does that make sense? All right. Now, key fact, surprising fact maybe, is that that claim, coins that had 50% of the time, is more likely given switchy than given sticky, and therefore is evidence for switchy over sticky. Not totally obvious why that's so, but you can see a few toy cases to get the idea. First, take a very short run version of that. The coin lands heads 50% on 2 tosses rather than 1,000 tosses or 1,000,000 tosses. Suppose I just tell you, I tossed it twice and landed heads once of 2 times, so 50% of the time. Well, that's equivalent to saying it either landed tails and then heads, or landed heads and then tails, which is equivalent to saying, I tossed it twice and it switched once. Of course, switchy makes switches more likely, and sticky makes switches less likely. And so switchy says you should expect that more than sticky does. So that claim is evidence for switchy. And that turns out to be true more generally. So if a process is switchy, it's more likely to end up roughly 50% heads because it's going to switch back and forth between them. If it's sticky, it's less likely because there's more likely to be a very long run of tails, for example, which skews the overall average. So if you start out with uncertainty about the causal process, whether the coin is switchy, independent, or sticky, and then what you update on is the fact that they tend to land heads half the time. That should give you a little bit of evidence for switchy over sticky, and therefore your average across those should be a little bit inclined towards switchy, which means you should do the gambler's fallacy. You should do the gambler's reasoning. You should be a little bit more inclined to expect the coin to switch, given your uncertainty about the causal process. And the paper more generally is on the fact that when you have, suppose in fact that the coin is independent, as coins are, well, coins are almost independent. There's a subtlety here, which we can skip over. Then, given limited data, very often a perfectly rational Bayesian will end up more confident of switchy than they are sticky, even if the process that's generating data is in fact independent process. And so we'll be a little bit inclined to perform the gambler's fallacy. So there are many contexts in which we should expect reasonable people to do this, given uncertainty about the situation.
No, that was all really interesting, and I'm looking forward to the paper. I'll definitely have to check out the blog post. But the last of the fallacies that I wanted to talk about was the sunk cost fallacy, or sunk cost reasoning. This one is particularly interesting to me because I remember when I was in undergrad, my roommate had purchased this really expensive flight and ticket to go down to some concert in Miami or something, and then he just decided he wasn't going to go even though he paid for it. And I thought this was just absolutely insane. And he was in economics, and he told me, no, it's the sunk cost. It's a sunk cost. And I was like, what are you talking about? And he said, well, something better came along, so I'm not going to do this just because I paid for it. And it was one of those biases or fallacies where learning about it really changed my actual behavior in the real world. It wasn't just something that I read about and then forgot. But maybe you could give a more precise layout of what sunk cost reasoning or the sunk cost fallacy is.
Yeah, sure. And a lot of my thinking about this is based on a great paper two great papers actually. One by Tom Kelly, called, I think, Sunk Cost and Acting for the Sake of the Past, and one by Ryan Duty called Sunk Cost Fallacy. It's not a fallacy. So different arguments that go into this. So the basic thought is, the observation that people very often let past costs or commitments or investments influence present decision-making. So buying a plane ticket and then feeling, I don't want to waste this plane ticket by deciding not to go to this concert, or it comes up in public discourse even. So Tom Kelly gives these examples of the Vietnam War. There were many public justifications where, like, look, we can't, when the war was not going very well, and in response to criticism, people would say things like, look, if we pull out of Vietnam now, then all this sacrifice will have been in vain. This is all just a waste. And we can't let the soldiers who died have their sacrifice be in vain. And that's, at least on its face, something like sunk cost. Like past investment is the rather economist cold calculating word for that, but influencing present, past sacrifice, I should say, is influencing present decision making. And the basic sort of classic economics reasoning for why the sunk cost reasoning is a fallacy is the thought that is actually somewhat motivated by at least often motivated by the Bayesian reasoning approach to decision making that we've seen, which is basically you should make your decisions so that they have the best, given your choices, choose the option that has the best expected value and most improves the situation given where you currently are. And the basic thought is, look, if it's a sunk cost, that's a cost you already paid. You can't get that money back. You can't affect. Using the plane ticket doesn't give you the $200 back that you spent on it, for example. And so you should treat, one way sometimes people think is like, you should treat sunk costs as like investments other people made, earlier versions of yourself, but you can think of it as another person if you like made. And then think, okay, well, that was past Kevin spent $200 on that airplane. I'm not going to get that $200 back. I would rather past Kevin have just given me $200 rather than give me an airplane ticket because I don't want to go to Florida. But given that he did spend $200 on the airplane ticket, well, I'm going to make the best choice for me given that, and that's do whatever it is that I want to do instead of going to Florida. So that's the basic reasoning behind why it's a fallacy. Is that clear?
Yeah, no, it's definitely clear. And then, cool. The last thing that I wanted to talk about was, I guess it's going full circle, but how polarization relates to irrationality and even to rationality. So maybe this would be a good time to talk about your work in politics and your upcoming Phil review paper. Congratulations, Rational Polarization.
Yeah, so I mean, this is, as I was saying at the outset, I got interested in this stuff about applied questions about rationality, in large part by thinking about what was going on in polarization in politics, and been working on a project on that for many years, and still working on it. So eventually it'll be a book. I decided recently that it's not going to be a book anytime soon. So hold your breath. There's a ton of talk about sort of polarization and its relation to irrationality. The basic thought being, sometimes gets bemoaned as a post-truth era, or the rampant spread of misinformation, which makes it such that sort of people on opposite sides can't even see eye to eye, are living in different worlds, or in politics sort of have such radically different expectations and beliefs. And the question is, like, how could that be so? How could, take your favorite political disagreement, how could Republicans think it's a good idea to, Ron DeSantis think it's a good idea to basically not tenure any of the faculty at New College, Florida, was some recent example, or from the Republican side, how could Democrats think, there's not a difference between men and women? Take your favorite controversial, hot-button political issue. A standard explanation is that look, people just are engaged in some sort of pig-headed confirmation bias, that they have their own political, maybe gut feelings, maybe beliefs instilled from an early age, that sort of thing. And when they're engaged in reasoning in political context, they systematically are selectively sensitive to information. As I was saying earlier, they sort of pay attention to information that supports their beliefs and dismiss information that doesn't. They tune into news programs that are sympathetic. They, when information is mixed, they tend to interpret it in a favorable way, that sort of thing. And they talk to people who are like-minded, and they come to disagree. And so that's a sort of standard irrationalist narrative of what's going on in leading people to disagree. I think a few ways into the particular project I have on this. One is just an observation that many people have made, that polarization, not just in politics, scientists are polarized, and polarized over all sorts of issues. I mean, not over everything, not to the same degree, but there are plenty of instances in academic fields or scientific fields even, where there are two or more camps of people who have very different opinions, and they have very different readings of the evidence. Keelan O'Connor, Jim Weatherall have a great example. They talk about at length. Other people talk about the treatment of Lyme disease. There's this question of whether, I forget exactly what, chronic Lyme, I think is the term. There's a question of whether sort of someone who gets Lyme disease can, and goes through a round of antibiotics, can have lingering symptoms for years after, whether further antibiotic treatments can be helpful for them. And this is obviously related to debates about long COVID in recent years. And it turns out there's just different camps of scientists who have very strong disagreements about that. And so you see polarization in cases like that, and many other cases as well. In my case, I saw it personally in my own academic department in grad school, where sort of not so much over politics, but over interdepartmental life. I was sort of on the border between two different social groups, and I could see sort of people interpreting the exact same situation very differently, and sort of having very different reads on what the department should do about it, that sort of thing. And obviously, maybe not obviously, but I thought scientists and people in my academic department are, broadly speaking, reasonable, well-meaning, trying to figure things out people, and they're getting polarized over things. So what's going on there? I know we've been going for a while. I know I'll let you decide how many details you want, but the basic motivation for the project is, well, how can we build models that are, broadly speaking, Bayesian models on which rational people can come to predictably disagree about things? For example, you have Bayesian or rational processes that lead to selective sensitivity to information, things like confirmation bias and so on. And the short answer is that you can. So what I was doing in much of grad school before I got interested in rationality was these models of, as I mentioned, higher order uncertainty, or cases where you have ambiguous evidence that's hard to know what to make sense of. And there's a sort of a surprising, weird formal result, not due to me, that I rediscovered and found due to colleagues named Duff Samet and Bernard Sallow, that in contexts like this with Bayesian models, sometimes when you have ambiguous evidence, you are guaranteed to have some sort of selective sensitivities, some sort of, we talk about, it's not intuitive why that is, but it's a theorem that comes out of some of these models. And that got me thinking, well, could this be relevant to thinking about selective sensitivities in real world cases? Because real world cases of bias assimilation of evidence are cases where the evidence is messy, conflicting, and hard to make sense of. They're clear cases of ambiguity, if anything is a case of ambiguity. Classic studies are like, you get two studies, one telling one thing, one telling the other thing, and you're trying to reconcile how to make sense of these two different studies. That's a clear case of conflict that's hard to know how to resolve. And so effectively what the paper is doing is showing that, first of all, you can have agents that are Bayesian in many senses, and in particular, expect rationally that getting new evidence and responding in this way is going to improve the accuracy of their opinions, but it's going to do so asymmetrically. They're going to be more sensitive to evidence that points one way than another way. And if you can do that and you can iterate that process, then you can see how reasonable Bayesians of a sort can predictably come to disagree, because I'm going to see evidence and be selectively sensitive to one side of it. You're going to be selectively sensitive to the other side, and we'll come to sort of slowly drift apart in our opinions. And the idea is to try to make good in the rational framework on how that sort of thing can happen to real people. So that was a little bit high level, a little bit details. Let me know if you want to hear more. Or yeah,
sometimes I get the difference between high level and low level confused, but maybe I'm going to go with high level here. But stepping back from politics for a moment, and I think this is where high level comes in, but staying a bit high level, under what sorts of circumstances would it be rational for agents to disagree? And under what sorts of circumstances is it rational for them to, I don't know which I said first, rational to disagree and then irrational to disagree? You get the picture.
Yeah. I don't know if I can actually give a non-controversial answer to that, but I'll give a controversial. I mean, I think broadly speaking,
controversy is good.
Great. Broadly speaking, if people at least started out with similar prior beliefs, and that's a big if, then when people have availability of similar evidence, then broadly speaking, you shouldn't expect disagreement. Maybe actually more interestingly so. If people start out with similar prior beliefs, even if they get very different evidence, they go, I go off to a liberal college and my friend stays in a conservative town. I use very often. And we know we get tons of very different evidence. We come back and talk to each other. Well, we find out we disagree. We should adjust based on that, or rather, the classic theory will say, look, I know I got some evidence. I know he got some different evidence. I see the output of that evidence, namely his final opinion, which is sensitive to all these little bits of evidence I didn't see. So I should respond to that final opinion and sort of infer we must have got evidence in favor of that opinion. It's a bit of the sometimes called evidence of evidence is evidence. If I learn that someone becomes convinced of something, if you learn that I become convinced it's going to rain in Boston tomorrow, you should become convinced it's going to rain in Boston tomorrow because I must have gotten evidence for that. And so in a classic Bayesian setting, there are what are called no agreeing to disagree theorem due to Robert Almet, which basically says when people start with similar prior beliefs, get whatever different evidence you like. If they come and later see each other's posterior beliefs, how they respond to that evidence, they should come to agree again. They should sort of average, it's not quite as, but something like average out their disagreements. And so those sort of results are a big puzzle for the possibility of rational polarization, because the thought is, look, everyone knows that conservatives and liberals have very different evidence. They vary in social circles, they watch different news, they talk to different people, they see different things. But they know of each other's opinions. And so you might think we're in a case where, well, I haven't been watching Fox News, I've been watching MSNBC or whatever. Watch either actually, but then talk to someone who has been doing the opposite. well, we've seen different things, but we should sort of price in what each other must have seen that led to those different opinions and come to some at least compromise a little bit. And people don't do that. And so there's a question is how could that be rational?
Right. So you said that evidence of evidence is evidence, which is another nice saying. And no matter what your political beliefs, say someone you respect intellectually has thought about issue X a great deal and has the opposite views of you, even if your credence in X opposite this person's is very, very high, should this affect your credence in your own beliefs?
I'll give you it's a simple question, but I can't give a simple answer. At least it's the problem of talking with people who think about this stuff too much. So yes, sort of a bit. So take a simple case where you have every reason to trust their reasoning process. Take the simple version of me, like, suppose we're wondering whether it's going to rain in the Sahara tomorrow, right? And we're pretty confident. You're very convinced it's not because it's a desert after all. And then you learn that I've done some research and I'm convinced it is going to rain tomorrow. That's a ton of evidence for you. You should just think, look, it's not that, I don't know exactly what Kevin did. He probably just like Googled it and looked at the weather, and like he trusts Google and I trust Google on rain predictions at least a little bit. I mean, failed me yesterday, but that's, other than that, okay. So in learning that I got evidence for it raining tomorrow in the Sahara, you got evidence. You should massively increase your degree of belief that it's going to rain tomorrow because you started out so low, and I clearly had very strong evidence. So in simple cases that works. I think the cases that are fraught and whereas with people are unsure whether to defer to experts or people have very different opinions, people have thought a lot about them more, it's not nearly so clear whether that's so. So this is relating to the notion of when you should defer to someone, be sort of disposed to adopt the opinions that they have or would rationally have given their evidence. And obviously sometimes in the weather case I just gave, you should, because I had strictly better evidence than you, and you like sort of trust my response to that evidence and so on. But in other cases, and this is part of what the rational polarization project I was working on is about, if you think the evidence, there are a bunch of conditions where you shouldn't do that. One is if you think I have a selective memory. So if you think, I decided forget the rain in the Sahara, I've decided I want to figure out, what the best gun regulation policy is. You know this, I'm going to go do a deep dive at some literature there. And let's suppose you don't have any strong opinions that disagree with me to begin with. If you expect that what's going to happen is I have a political agenda and I'm going to remember statistics that fit with that political agenda, like that we should regulate a ton more, and forget statistics that don't, then you definitely shouldn't defer to me. Right? You shouldn't sort of, if I come back later and say, I'm convinced that we need to regulate guns with a much more heavy hand, that's some evidence for you because it tells you that I found some evidence, but you sort of were expecting that all along, more or less. You were thinking, look, Kevin's probably going to find like a mixed morass of complicated data. He's going to selectively remember some of it. And so he's going to come back convinced. Given that you sort of predicted that at the beginning, you shouldn't be that surprised when I come back and say we should regulate a bunch. And so you don't get very much evidence. And I think something similar can go on in other cases without, this is broadly speaking what the polarization project is about, in other cases without information loss, that when evidence is asymmetrically ambiguous in a way, when you think I'm going to be selectively sensitive to information in a way, there's a sense in which you would think I might respond, broadly speaking, rationally within some limits, and still think I'm not going to completely defer to the opinion that comes out of it. Because I think even rational people are liable to go off the rails into these sort of contexts where evidence is conflicting and ambiguous and that sort of thing. So that's a long answer to a simple question. I think the basic thought is everyone knows that in some basic, simple cases, clearly you should defer to when people have disagreeing opinions. And everyone's suspicious in like very complicated political charged cases about deferring to other people's opinions. I think this sort of speaks to, yes, that makes sense to have that sort of different set of disposition.
One last question on this issue in particular is, I saw on your Twitter bio, you write that you're trying to convince people that their opponents are more reasonable than they think. And I'm wondering if the rough idea behind this thought is that your opponents are probably reasoning well enough, they're just drawing on a different body of evidence from you because they live in a different echo chamber, / they might just they're coming into the quote unquote reasoning arena with different priors.
Yeah, I think that's right. Not so much the priors thing, but in terms of the sort of people having both very different and I guess one way to put it is it's extremely easy to underestimate how much evidence people have relevant to some, say, political claim. So political scientists will classically say, when it comes to political knowledge, the variance is high and the mean is low. People don't know much about. And that's certainly true if you are like quizzing people for political facts about sort of who's on the Supreme Court or what have you. But people have, once you're a Bayesian, you realize that, things are evidence for things that make them likely or make them more likely. Here's a bunch of things that make, say, we should regulate guns more likely. I read a news story where someone got shot. My friend thinks we should regulate more. The person who says we should regulate less is an asshole. The person who sent me this study suggesting that we should regulate less also sent a study about why abortion is bad, or if I have the right sort of price. So all these little things, I mean, we are confronted with evidence relevant to our political opinions every day, all the time, at least just from the opinions of our friends and what people's opinions are about other people's opinions and so on. So no one can track all that stuff. There's a ton of it. And the basic thought that everyone has, therefore, extremely different sets of evidence. Moreover, that evidence is not like the weather case, not like the weather in the Sahara case, where there's some clear bit of evidence I can get, which makes sense. There's a clear thing to know what to do with it. Rather, it's messy, complicated. There's a whole range of facts that sort of everyone agrees that can point in different directions. And of course, depending on which ones you attend to, it call to mind or that sort of thing, it's going to make a big difference on your overall take on the whether we should regulate guns more and that sort of thing. This is one of the reasons why, for anyone out there who is a theoretical academic who wants to start getting involved in empirical work, you might have a response I did, which is like, I can't keep track of all these empirical studies. And so at some point in grad school, I started doing a memory app called Anki, which is a way basically, it's called power law learning, a way of memorizing. If you have bad semantic memory, you just get quizzed on these things at some intervals. And it's a long story. The relevant thing is I just started throwing in a bunch of statistics that didn't fit with my prior beliefs, because otherwise I knew that I was just going to, when I started learning about these things, I was only going to pay attention to yes, that fits the narrative. And I find that's a very useful thing to do. And people, generically, there are only so many relevant political considerations that come to mind, and the people who disagree with you a lot are going to do so based on very different bodies of data. And so it's reasonable to expect disagreement. Moreover, and I think this is the other part of the convincing people that their opponents more rational than they think, it's very easy when you see very strong disagreements to reach for, the off-the-shelf irrationalist narrative from behavioral economics and the heuristics and biases psychology literature that basically says, people are bad at responding well to evidence. And so a lot of work I'm doing is pushing back on that. And I should say, a lot of psychologists are pushing back on that. So there's, for decades now, there's been pushback to the heuristics and biases program. And I think there's, fair to say, a sort of emerging new consensus or paradigm, or what's sometimes called resource rational analysis, the thought being that, look, we did this sort of irrationalist psychology for a long time, and we found a long list of apparent cognitive biases with no real rhyme or reason to them, and not that great much better predictive accuracy of psychological theories. turns out we can unify a lot of them with the assumption that people are, broadly speaking, doing a Bayesian thing subject to resource constraints. They're rational subject to the fact that they have limited cognitive limitation. And part of the picture is, a totally reasonable approximations to rationality lead to a lot of the apparent biases and apparent irrationalities people see. So that's the other way of pushing back on the making people think their opponents are more reasonable than they otherwise would.
Well, I'd like to end with a question that's a bit abstracted from the line of inquiry we've been following, and it's a bit more practical. So I'm wondering if you have any advice based on your research and thinking for people on how they ought to conduct themselves with other people in areas of deep disagreement, like the political arena we've been discussing.
Yeah, let's see what things are in the memory app. You don't need any psych research to tell you that the way not to engage with people who disagree with you is to sort of attack them and sort of show disdain and have say you don't trust their sources and all that sort of basic sort of things that give people hackles raised. And you don't need to appeal to any irrationalist defense mechanisms to explain why people get their hackles raised when you start criticizing them and their beliefs. A lot of the research, most of the research suggests it's hard, obviously, to talk across the political and other deeply divided aisles. But things that do, as far as I know from my read of the literature, work better is sharing personal experiences is a big driver. Emphasizing common identities is a big driver. So there was this lab talk I was in recently where they had run, they had solicited hundreds and tested dozens of different depolarization mechanism interventions where they basically tried, how can we get people to dislike people from the other party less? For the record, those numbers are skyrocketing. So between 2000 and 2021, the rate at which Democrats and Republicans said they strongly dislike the other side tripled. So from 15 to 20 to 50 to 60%. And the most effective interventions they found are things like, videos that emphasize sort of ways in which people have things in common. So here's one document finding called the perception gap, which is that people tend to have accurate opinions about the opinions of their own party and inaccurate opinions about the opinions of people from the other party, sometimes by massive gaps, 30 to 40% percentage points misestimates. And so sort of paying attention to things that you agree about, and certainly, and approaching it with curiosity and questions rather than an agenda, I think is pretty clearly approaching it without sort of being while still expressing your own opinion. So two books that one I've read recently, one I am reading now, both of which give an interesting insider take on it. So one is Unfollow by Megan Phelps Roper, that people may have heard of, is the story of Megan, who was raised in the Westboro Baptist Church, which is an extremist political group, and telling the story of what it was like to be in that group and sort of start to interact with people outside that group and slowly start to change her mind. And it was, of course, a process of having sort of, broadly speaking, civil dialogue with people who had disagreed and but knew things she knew. In her case, knew the Bible well, and we're talking about biblical interpretation. Another is Rising Out of Hatred, I believe it's called, which is a story of Derek Black, who was being raised as sort of the next generation white nationalist in the white nationalist movement in the U.S. and around the 2010s went to college and had this sort of eye-opening experiences of talking to people, and was raised thinking all the things white supremacists and white nationalists think, that sort of people are smarter, better, etc., Jewish people and non-white people are terrible people, and then he made friends with them. And they weren't talking about politics. They made friends with, someone from non-white friends and Jewish friends, and that's the sort of thing that started to change his mind. I mean, there's many more things to say on that front, but I think the sort of thing that both empirical data and stories like that make very clear is that sort of realizing people are humans and people have reasons for their beliefs, even if you don't think they're good, even if you don't think, like me, that they're rational, and try to see where they're coming from. It's generally the way to engage.
Well, Kevin, this has been a great addition to my growing bestiary of episodes on rationality and irrationality. So thanks so much for your time and talking with me about this.
Thanks so much. It's been a lot of fun.
Hold on, Geeslings. Before you go, please like, subscribe, follow if you haven't already. Smash all those buttons. And also, if you haven't followed me on Twitter at Robinson Earhart, or if you're not joining me every morning as I eat my pint of ice cream on Twitch at Robinson Earhart on Robinson Eats, please do so.